Good day, students. So, today we will look at the conformations of ethane. So, ethane, as you all know, has the general formula C2H6, and we will represent this as CH3 CH3, and I will label this the first carbon as C1 and the second carbon as C2, and the two carbons are connected by a carbon carbon single bond. Because the two carbons are connected by a carbon carbon single bond, the carbon carbon bond is free to rotate and can give rise to infinite number of conformations because the angle between this angle between, say for example, an h and h can be anything from 0 to 360 degrees, right? So this angle between this torsion angle between HCCH, okay, so torsion angle between the planes formed by HCC and CCH can be between 0 to 360 degrees, and hence we can have infinite number of conformations. But there are the most stable conformation is called as the staggered conformation, and the least stable is called as the eclipsed conformation. So this one is the most stable, whereas this one is the least stable. Now to go from an staggered conformation to an eclipsed conformation, or we can say that to go from one staggered conformation to another staggered conformation, ethane has to pass through an eclipsed conformation. So between one eclipsed and between two eclipsed conformation there is a staggered conformation, or between two staggered conformation there is a eclipsed conformation. Now let's look at this in more detail now. So this can be represented as in two representations which we are aware of. The first one, which is called as the Saha's representation. So here what I label as one is the eclipse conformation, which is the least stable conformation, and the one which is a staggered conformation is the most stable conformation. And in the Newman projection, we can draw the eclipse conformation as shown below. And here we are looking from this side, with from the red carbon being the nearest to the eye. So this carbon is the red one, and here too this carbon is the nearest carbon. So this is the red carbon which is indicated here. Okay, right. So now let's look at the different conformations of ethane and the free energy profile of the same. Now let me draw the eclipsed conformation of ethane. So I will draw with, okay, I will draw with the red one, which is closer to the eye, and then and the carbon which is at the back in black, and so we have an eclipsed conformation. So, and let me label this as H1, H2, H3, H4, H5, H6. Now the angle between the torsion angle between H1, C1, C2, and H4 is equal to 0 degree. So this stands for the torsion angle, or it is also called as the dihedral angle. Dihedral angle formed by the plane H1, C1, C2, and C1, C2, and H4. So the dihedral angle formed by the plane C1, H1, C1, C2, and by the plane C1, C2, H4 is equal to 0. Now let me just draw what happens if you rotate rotate, or if you change this torsion angle by 60 degrees. So let me draw the H4, H5, H6, and let's assume that, let's fix the positions of all the hydrogens which are attached to C1, and only rotate the hydrogens which is attached to C2. Now if we rotate this by 60 degrees, so this is an eclipsed conformation, and if we rotate this by 60 degrees, it gives rise to a staggered conformation. So you have H5, so, sorry, this should be H4. So you have H5, H4, H5, and H6. Again, if you rotate this by 60 degrees, so this is your H1, H2, H3. Again, if you rotate this by 60 degrees, you will get H1, H2. You will get another eclipsed conformation, H4, H5, H6. If you again rotate this by 60 degrees, you we will get another staggered conformation. Now the leftmost thing, the representation on the leftmost thing is an eclipsed conformation. Now let me rotate this. Now let me fix H1, H2, H3. That is the carbon, that is the hydrogens that are attached to the front carbon, which is colored in red, fixed. Whereas I will just rotate and move around the hydrogens that are attached to C2, which is represented by black. So we start with an eclipse conformation, and if I rotate this by 60 degrees, you will get an staggered conformation. And if we label this as so H4, H5, and H6, again if you rotate this by 60 degrees, you will get another eclipsed conformation, H4, H5 and H6. Rotating this by again by 60 degrees will give rise to its another staggered conformation. Rotating this by another 60 degrees will give rise to another eclipsed conformation. And rotating this by another 60 degrees will give rise to another staggered conformation. Now rotating this by another 60 degrees will give rise to the same eclipse conformation that we started off with. Now let us label this as A, B, C, D, E and F. Now in the eclipsed conformation, the hydrogens which are in the front are exactly overlapping with the hydrogens which are at the back, and hence there is a small amount of repulsion between the electron clouds of H1 H4, say H5, sorry, H2 and H5, H3 and H6, because they are exactly behind one another, and hence there can be a slight clash of the electron cloud, and hence this eclipsed conformation are slightly higher in energy than the staggered conformation, because in a staggered conformation the hydrogens are not exactly behind one another. So the hydrogens are not exactly behind one another, and that minimizes the repulsion between the hydrogens in the front and the hydrogens at the back. So because there is more distance between the two, there is less repulsion, and consequently staggered conformations are more stable than eclipsed conformation. So here is the potential energy diagram of all the conformations of ethane obtained in one complete 360-degree rotation about the CC bond of ethane. So you will notice that the staggered conformations or conformers are about 2.9 kilocal per mole stable than the eclipsed counterpart. That is, staggered conformation is lower in energy by 2.9 kilocal per mole, and if you talk in terms of kilo joules, it will be kilojoules per mole, and hence we can notice that why staggered conformations are more stable than eclipsed ones. In the next video, we look at the different conformations that are possible for N-butane. From the viewpoint of exam, this figure is very important, and also you have to label these angles and properly along with the axis of x and y. So see you with the conformations of N-butane.